So, on the last part we've seen how we can move on to angled and vertical surfaces. Okay, we have all of this, we're moving around. Obviously we don't play any animations, we're actually only going to play 2 animations with this, and you'll see how it's going to look. And in this part we're going to start working with the first part of our arcade. So let's go into our scripts and let's create a new script which we're going to call free climb animator or anim hook. Enable that, close this, delete all of this. I'm going to add my namespaces as always. Okay, now the thing is with this animator, with this script, it needs to go on the same position as the animator of our model. So it needs to be on this level of the game object. Okay, so free climb animator hook. We're going to have an init because we're going to be using this from our climb. We're going to be initializing this from our climb, and I'm going to be passing my free climb C, and from the C I'm going to get the animator, which is this. We should pass a few more other things, to be honest, but for right now let's leave this out over here. Basically this script is going to be what we are using to place our key into the correct positions. To do this we need to have, we're going to create a new class. Let's do this on the free climb though, and let's create a new class. Let's call this IK Snapshot, and let's serialize it. And all this in here we're going to need the vector 3, right hand, left foot, right foot, and also we should create okay, let's do this later. In our free climb script let's create public IK snapshot and base IK snapshot, and this is the snapshot where everything that has to do with our IK is going to be based upon, because we can set this from the inspector. Back again into our climb animator hook. Let's create the IK snapshot for the base, IK snapshot, and say IK base, and then IK base, let's assign the one we have into our base IK snapshot. Okay. Then we need 2 more IK snapshots. We need to have our current new IK snapshot, and then we need to have our next IK snapshot, which is this 2. And then we need to go and say, we basically need to use the built-in functions the animator uses. For example, void on animator IK, let's see. Okay, let's take it from the start and let's go over them again. Okay, we have our base IK, we have our current, we have our next, and then we're going to need a few more things, which is a public float, the weight for the right hand, another float, the weight for the left hand, the weight for the left foot, and the weight for the right foot. Okay, goals, no, okay. Then we need to have the actual positions we're going to be assigning are arrays, which is going to be as a vector 3, and we also need to have a reference to our helper. For the helper, it's easy. We're going to say h, and we can pass it. We still pass the free climb, but I don't want to make the helper public in my free climb, so I'm just going to be doing I'm going to be passing it along with my init. Okay, so let's say we want to move. We're going to be passing an origin point, which is basically this is going to be our point, and from that point we're going to be creating new positions. Okay, that is really simple. To do this, then we need to have a few more stuff. For example, we need to have a public array snapshot. Let's call this create snapshot. We have our origin over here, and that's going to create a new array snapshot and then return the R. Let's create an encapsulated function that's going to help us with the calculations we want to do, and we're going to be turning the local positions into world positions, and the P is going to be the target position. So on our vector 3 R, we're going to use our helper dot position, and then helper dot right, we're going to multiply p dot x plus helper dot forward multiplied by p dot z, and of course r plus, oops, no, this is correct, helper dot up multiplied by p dot y. So returning that R. So what we're doing here is basically we are creating a position, a vector 3 position. For example, let's say that if you want to, when you are on the base position, you want to have your array for the right hand to be on +1 on the x and +1 on the y. But if the angle has changed, if the angle is like this, you need to calculate it based on your own transform. Our own transform tends to move around because, you know, we move from place to place, so that's where the helper is going to be used at. Because we teleport the helper, we don't have to worry about, you know, in between rotations. We only need to know the final position, and that's where the helper comes into play, because we say, for example, if we hit play at this moment, if I wanted to place, in this case, if I wanted to place my hand over here, then that will be really simple. But if we were up on a position, or maybe in a position like this, let's see if we could go over there. Okay, things get a lot more complicated because there's no position over here like this, so it needs to be recalculated again from this direction. The simplest way to do this is what we just wrote. I hope that was clear enough, but basically that's what this is doing. So into our array snapshot right now, we have our left hand is going to be local to world, base, the array base dot left hand, then on to our right hand, local to world, array base right hand, left foot, local to world, array base dot left foot, right foot, local to world, ik base dot right foot. Okay, and then return that as it is. Let's create a few more functions that they are going to be useful. For example, copy snapshot. We're going to be passing a referenced ik snapshot to and ik snapshot from, and basically to dot right hand, from dot right hand, to dot left hand, from dot left hand, to left foot, to from dot left foot, and then to right foot from right foot. Okay, awesome. Let's create one that is going to help us when we want to update an ik position. We're going to be passing an ik goal. And the target position. Then with a switch with just our goals, I'm going to say LF will be the position, or it's going to be RF the position, or the left hand is going to be that position, or the right hand. Okay, so we have our functions. We also need to have a function that updates our weights. Let's write one as well. And let's copy this and say update ik weight. We still need the goal, and instead of a position we should be passing the weight. Okay, so this will be left hand weight, left hand weight, and then right hand the weight. Okay. So let's say that we need to have now, let's try and see where we are at. So I think it's going to be easier to understand. Create position, we have an origin. Okay, we're going to start with an ik snapshot. We're going to create a snapshot, create snapshot, pass the origin. The functions we just made are going to take care of everything. We're going to copy the entire snapshot into our current snapshot and then set the ik. Before we do that, on init we should be also doing, well, they are already initialized, so I guess we already done that. We're going to copy the snapshot and then update ik position for the left foot. Okay, current dot left foot. Copy this, paste it 4 times and change everything. RF, right foot, left hand, right hand, and right hand. Then update ik weight, ik goal. Let's start with the left foot, and we're just going to say set it to 1. copy this 3 times, right foot, left hand, right hand, and there is what is responsible into creating our positions. Inside on animator IK, let's encapsulate a function which is going to be set IK positions. We're going to be passing our avatar IK goal with our goal, a target position, and the weight. So it's simple as saying set IK position, goal, and the target position. And before we do that, set IK position weight, goal, and the value. On animator IK then, set IK position, left hand, the weight for the left hand, set IK position, avatar IK goal, right hand, RH, W, RH, set IK position, left foot, LF, weight, LF, set IK position, avatar IK goal, right foot, RF, RF. And that is for our on animator IK. We're going to add a lot more stuff in the future, but let's test this to see where we are. To do this, we need to go and let's create we're going to just make this public for now. Free climb animator hook, and let's call this a hook. On init, a hook equals, we already have the equals. On init, pass this and pass the helper as well. However, we still need to be able to create our position. We still need to call or make calls for the positions. For example, on the first one we can check or we can do is on getting into position, which is down here. We can say a hook create positions on the target position you are right now. And similarly, we can do the same when we are initializing our lerp. So if you're not lerping over here, when we find the position we want to lerp at, we can say create position over here. Let me check one thing. Yeah, no, it's correct. Minimize, hit, we need to adjust the animator hook. This is our base IK snapshot. Because everything is at 0, it's going to place everything right on the point. So I'm going to say put the right hand on position maybe, come on, on Y5 and X2. It doesn't matter, it's going to place it somewhere. I don't really care for this. Why it's not working? The weight is at 1, so that means we forgot to go over here into our layer IK pass. Okay, if you don't tick IK pass, there's not going to be any IK. Okay, and you can see that the IK is at the correct position. And whenever we move, not only we can, we can compete against Monty Python for the Ministry of Silly Walks. We can also create our own league, the Ministry of Silly Climbs, as you can see. Okay, but the important thing is that it's working. It's actually doing exactly what we want. Of course, I just realized this is pretty sexual, but anyway. Okay, if I change now and find the correct positions for all of this, to whatever we need, it doesn't really need to be something specific. Well, it has to be something specific to look correct, but as you can see, I think the left hand might have some issues. No. Okay, everything is working as it should. So we're actually moving, we are lerping from position to position. Of course, it now clamps, and this is, you can see it, how this happens. When we are lerping between one position to another, it just automatically places the arcades on that position. What we want to do is take it from one position and place it onto the other. The byproducts of what we have just made, instead of just funny GIFs, is it's also angle, it doesn't really care, it's going to find the correct position based on the angle. And of course we have one slight issue over here. But yeah, we are really at the correct position. This is what we actually want to make, even if it's that horrible. Okay, this is really awesome. So this enables us on a lot of possibilities, even if it's a little bit horrible at this time. Changing this now, let's find, I don't know the correct values to use at this point, so we'll see what these are going to be. And let's go with 1.5, left foot, let's say -1 and -0.8, I don't know, and this, let's say this, set this at 1 and 0.8, just to look a little bit better. Okay. Anyway, feel free to pause and laugh. As you can see, this is basically just tailoring at this point with this until we find the correct one. But we also need to be moving forward. One way to do that will be to just assign this manually, but a better way to do that will be to make this automatic via the scripts. Okay, awesome. Let's go then into our climb script, into our free climb animator hook, and let me check one thing that I want. So basically what we need to be doing now is whenever we try to place an arcade position, we should be creating, or we should be trying to find the actual position it needs to have. So let's test this. This is going to give us the position it needs to be around. So technically I'm saying, and let's only try it with the right hand, maybe the left foot, because it's going to look funnier. Let's say that we have a vector 3, right hand, local to world, arcade base, right hand, And let's say that from that right hand I want to, okay, let's encapsulate this. It's going to, we want to return a vector 3. Let's say get position actual, and we're going to be passing the origin, and the direction is going to be the helper.forward. So here's what I'm going to say. I'm going to use the origin. It's the base position we just found from that, but I want to go a little bit backwards from there and say add on that the helper, the h.forward, and I'm going to multiply this by an amount and actually use the opposite. Oops. H forward multiplied by maybe 0.2. This is going to depend on what ledges you can grab that are behind you. Okay, keep that in mind. And then the direction is going to be h.forward, or if you want to be a little bit cleaner, you can write this like this. Say, oops, not decimal, dir, then do a raycast if, and actually let's create a return value as well. If the raycast doesn't hit anything, then it's going to get assigned into this one, or it's just going to return you the base one. Okay, origin, direction, the distance you want to go now, it depends on how much further in you can go, and this will also have an out hit, which we need over here. Raycast hit, out hit. If we hit something, then that target position, the R is going to be hit.point, return R. We should probably add an offset as well from the wall. So let's say R will be hit.point plus hit.normal. Let's say wall offset, let's go with 0. Okay, let's go with 0.1 and we'll see what that's going to change. Multiplied by your wall offset, and R is going to be R. So R dot RH is going to be get position actual RH, and let's change the left foot as well, because why not? Vector 3 LF local to world IK base LF, and then R.LF get position actual LF, and remove this. Okay, save, and let's go and try this out. You can see it more clearly on the leg. The right hand, for some, it still has a different Z value, but I think the 0.1 is way too great for it for some reason, which I don't particularly understand at this point. The hand is actually working, unless we forgot to remove something. Let's maybe change the offset. Let's change this to 0 so it sits directly where the IK position is, or where the hit point is. Oh, I think it's just way too high for him to reach. That's why it's looking at like that. Oops. We don't have to put anything on the Z. So let's maybe change this to 1 or maybe 0.5 by 0.5. Okay. Still is way too high for him. Let's maybe bring it in. But as you can see, it's just a matter of finding the correct values at this point. Let's do 0.29 then. Let's do let's do 32 so it doesn't sit on the exact same position. I think we can maybe change this to 7. Let's do 72 over here. But you can see that it still starts to get, it's starting to get shape. Of course, we're still doing funny things, but you can see that it also adapts to the terrain, or however you want to call that. Okay, let's go over higher. This happens because we actually hit on this right on the center. This can happen. We're going to fix that as well when it's time, don't worry. Or you can keep it in because it's still funny. But here's the nice thing is that, as you can see, it starts getting adapt. It really starts to adapt on different angles. So we're hitting on this position and we have one leg hitting on this angle and this one on this angle. So this is really cool, as you can see, because we basically adapt into terrain. Let's try the other extreme angles we have over here. Like this. Of course, yeah, okay, it needs a little bit tailoring. It's not perfect, but it doesn't make it. We're getting there. Let's see. Okay, you can see he has one hand somewhere else. He cannot reach the raycast position over here. That's why it's super extended. But yeah, as I said, we are getting there. So, since this is working, let's turn everything into this way. We do start to introduce a little bit more of an impact, but doesn't matter, it still looks pretty great. Hand, local to world, IK base, left hand. Left hand, and then change this vector 3, right foot, and then r.rf, get position actual, right foot. Oops. Save, minimize, play. Which is a motto all of us can get behind, I guess. Okay, and we have more adaptable on the terrain, especially, well, even though this is wrong, you can still see how adaptive it can be, because you still get one foot that doesn't find something just sit on the idle, and let me assure you that that's the way it looks on Assassin's Creed as well, if you don't find a position. But yeah, things get a little bit different over there. What? And we still don't have any colliders. I don't know if you have noticed. We have no colliders inside our controller or scene. Well, to our controller we have into our scene, we have colliders. But anyway, you can see that things now get a little bit more interesting, or at least a little bit more. Let's see. Well, they tend to look a little bit more like an actual climb system, because we also adapt onto the terrain we are moving. Okay, this is really awesome. Hope you can see this. And you can guess where this is going. So, let's end this one over here. It's a little bit shorter, but I think it's a good stopping point until you get how this thing works. In short, if you want to do an elevator pitch, if you want to encapsulate this into a small statement, how it works: we are on a position upon a collider. When we are moving, we are basically searching around us for a viable position. When we find a viable position, we recalculate the arcade positions, basically where our hands and feet should go. We have a base for the X and Y, so upwards and forward, and and horizontal, vertical and horizontal, and the depth, so how far in the hands can be. We do that with a raycast, which means we can also adapt onto the terrain. For example, let's start this again. If I go now and create a cube over here and just place it over here, just a little bit forward, and move above. Now we are hitting this here, so maybe I should bring this over here. Let's bring the guy forward a little bit. That's not the guy, that's the guy. Okay, you can see that it adapts on different height, which is really awesome. And not to mention that this can actually be dynamic as well. The arcade is not dynamic, but you can, if you want to do arcade, you can do the raycast every other frame or something, or even every frame, but I don't think it's going to be a reason. Unless you are moving, I don't think there's going to be a reason why you should be moving the arcade as well. Okay, awesome. So, as I said, let's end this. You know what to do. Like, subscribe if you like to see more. If you like to support me so I can keep making more, then you can do so on Patreon. You also get additional rewards depending on your pledge. The other way, of course, is via Gumroad by buying a project or 2 or 3 or 4. This also is going to be added on the same project as the old climbing system. So when this is ready, you're going to be having 2 climbing systems, and later on in the year, probably in the next year, we're going to be redoing the old climbing system as well. So we're going to make this even better, and you're also going to have access, well, in the end you're going to have access into 3 different climbing systems. Okay, there's still a lot to do till then. We have 1,000 things to do, so I'll see you and climb again next time. And I'm going to leave you with this screen. It's another form of twerking, as you can see. Anyway, I'll see you next time.